Good morning students, welcome to all. For this session we see the entrance class. In unit 2 discuss the question. Okay, so question number 1, the quantum numbers n equal to 2, l equal to 1 represent. Here option is given. Okay children, quantum numbers we know very well. There are 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number. Okay, here principal quantum number as well as azimuthal quantum numbers values given. So from the, n as well as l we find out the orbital. Okay, so now n equal to 2. Okay, and L equal to 1. Children, this one you know very well. L equal to 0. It denoted s orbital. L equal to 1 denoted p orbital. L equal to 2 d orbital. L equal to 3 f orbital. Children, for this lesson this concept is repeated again and again. Okay, so keep in your mind, L equal to 0 s orbital, L equal to 1 p orbital, L equal to 2 d orbital, L equal to 3 f orbital. Here L is equal to 1. So L is equal to 1 means it denoted p orbital. Okay, so now write the orbital 2p orbital. Now check the answer. 1s, 2s, 2p and 3d. So the correct option is 2p orbital. This is the correct answer. Once again, the quantum number, 2 quantum number is given. N denoted as the principal quantum number. L denoted as the azimuthal quantum number. This alone, that is denote value if it is 0 s orbital, 1 p, 2 d, 3 and d f. So write the orbital. So the correct option is option C, 2p orbital. The next question, number of unpaired electron is 1s2, 2s2, 2p3. First we must know the meaning of unpaired electron. Children, even the previous video I taught about s orbital, p orbital, d orbital and how many electron, orientation, okay, everything I taught in the previous session. So here for example, s orbital, 1 orientation. Okay, 1 orientation means 2 electron it is possible. Okay, so now if here present, if it is present 1 electron, we use the word as unpaired electron. But at the same time, if it contains 2 electrons, we use the word paired electrons. Okay, paired, unpaired. Okay, so in p orbital, 3 orientation. Okay, d orbital, 5 orientation. F orbital, 7 orientation. 7 orientation. Okay, so in p orbital, number of that is number total 6, because per orientation 2. So 2, 4, 6. If it contains 6 electron, we say as paired up electron. Maybe if it is 1 electron, 2 electron, 3 electron or 4 electron, okay, denoted as unpaired electron. A simple way we explain, within the box 2 electron it is present, denote the word as pairing. If within this one degenerate orbital, okay, even any one orientation, if it contains 1 electron, we use to say the word as unpaired electron. Okay, so now come to the question, 1s2, 2s2, 2p3. So first 1s orbital. So s orbital means 1 orientation, 2 electron, 1s. Next 2s. Okay, so 2s, s orbital, 1 orientation, 2 electron. Here p orbital, this one for 2p, three axes, x axis, y axis and z axis. 3 electrons. So 1, 2, 3. Okay children. So this one based on the rule. First to write the fill the singly occupied. Next to start the pairing. Okay. According to that is a Hund's rule. Okay. So now here what is the total number of unpaired electron? 1, 2 and 3. Okay. So now see the question. Number of unpaired electron is 1s2, 2s2, 2p3. Okay. So here option 2, 0, 3, 1 is given. So what is the correct option? Unpaired electron 3. Option C. Okay. So and another one. Here total number of electron 3 plus 2 5, 5 plus 2 7. So what is the total number of electron? 7. So number of electron 7. What is the element? Nitrogen. Nitrogen atomic number 7. Number of electron 7. Okay. So mass number 14. So this one keep in your mind, nitrogen. So 1s2, 2s2, 2p3. This element is denoted, the particular element is nitrogen. Atomic number 7, mass number 14. Number of electron 7, number of proton 7. Number of neutron also 7. Neutron mass number minus atomic number. So 14 minus 7, 7. Children, next question. Azimuthal quantum number define. Okay, this is second quantum number. We know the symbol azimuthal quantum number symbol L. Okay. For the principal quantum number, talk about the size and how many electron it is possible for each shell. Okay. So in azimuthal quantum number, talk about the angular momentum. So angular momentum means you know the formula mvr. Angular momentum, mass into velocity into radius. Okay, equal to root of L into L plus 1 h by 2 pi formula. Okay, root of formula mvr equal to root of L into L plus 1 h by 2 pi. Okay children. So now come and read the option. E by m ratio of electron, spin of electron, angular momentum of electron, magnetic momentum of electron. Okay. So this E by m ratio of electron, so it is not relevant to the topic. Okay. So here this E by m ratio talk about the particle nature of electron. Okay. This one only proved by this concept E by m ratio. Next one, spin of electron. Talk about the spin. In spin quantum number, talk about the spin. Okay. But in azimuthal quantum number, can't able to discuss the spin of the electrons. And next one, angular momentum of electron. Okay. So the correct option is angular momentum. In magnetic momentum, here in azimuthal quantum number, it is not possible to talk about the magnet. Okay. Magnetic nature. Okay. So only discuss the angular momentum. So formula root of L into L plus 1 h by 2 pi. So the correct option is option C, angular momentum of electron. Okay children. So in principal quantum number, talk about the size. Azimuthal quantum number, talk about the subcells and orbitals. So this orbital, that is electron, revolve around the nucleus in a circular path. So now that is talk about the electron angular momentum. Okay, so revolve around the nucleus in the particular path. So here azimuthal quantum number discuss about the angular momentum of electron. Next question, which of the following explain sequence of filling of electron in different shell? Okay, sequence of filling of electron. Here option Hund's rule, octet rule, alpha principle, all of this. First all of this. Okay. Next one, alpha principle. We know the rules of alpha principle. In alpha principle, electrons are filled in increasing order of energy. Okay, so octet rule, oct number 8. Okay, the outer valence shell, it contains 8 electrons. Okay, it is satisfied for the or to attain the noble gas configuration. Next, Hund's rule. In Hund's rule, that is no sparing takes place until all the orbitals are singly occupied. Okay, so now you know one by one. Okay, the option, we know the explanation. So now read the question again. Sequence of filling of electron in different shell. So this concept is explained. Which one is the correct one? Alpha principle. Okay, so alpha principle, filling of electron in, that is orbital, 1s orbital, 2s orbital, 2p orbital, 3s orbital, 3p orbital. Okay, 4s orbital, 3d orbital. So filling of electron in different shell. So this concept is explained by Alpha principle. So the correct option is option C, Alpha principle. The next question, the energy E1, E2. Two energy values given. Two radiations are 25 electron volt and 50 electron volt respectively. So E1 value this much, E2 value this much. The relation between their wavelength lambda 1 as well as lambda 2. Children, we studied in the topic de Broglie equation. Okay, so de Broglie equation, we know the formula lambda is equal to h by mc. Okay, so lambda is equal to h by mc derived from the Planck quantum theory and as well as Einstein. Okay, so now write the formula E equal to h mu. Okay, so mu formula C by lambda. So E equal to h C by lambda. Now here two energy values as well as wavelength lambda 1 and lambda 2. So here consider E1, here lambda 1. So same way for E2 equal to hc by lambda 2. Okay children, so now derive the lambda 1 relation we are going to find out. So now E1 by E2, E1 by E2 equal to E1 formula hc by lambda 1, E2 lambda 2 by hc. So hc cancel. So E1 E2 by E2 equal to lambda 2 by lambda 1. Okay, so now in the question E1 25. So write 25 electron volt cancel. Okay, so next E2 50 equal to lambda 2 by lambda 1. So 125, so 225 are 50, so 1 by 2. Okay, so now 1 by 2 equal to lambda 2 by lambda 1. So cross multiplication, so 2 into lambda 2 equal to lambda 1. That's all. So this is the relation between lambda 1 and lambda 2 for the energies E1 and E2, 25 as well as 50. So now read again energy symbol E. So 1 as well as 2. First level, second level. Radiations are 25 electron volt, 55 electron volt. The relation between their wavelength. Wavelength symbol lambda. First level, second. So 1 and 2. So this relation they discussed using the de Broglie relation. So de Broglie formula lambda is equal to h by mc. This one de Broglie. This formula is derived from E is equal to h mu. Okay, mu formula, mu is equal to C by lambda. So we consider 1. So here E1 and lambda 1. So substitute the value and find the relation. Okay, so now check the answer. Here lambda 1 equal to lambda 2, lambda 1 equal to 2 lambda 2. So lambda 1 equal to 2 lambda 2. So the correct option is B. Next question, wavelength. Wavelength symbol lambda. Of Planck constant. Okay. Values given. Planck constant value. Planck constant H. H is equal to 6.623 into 10 power minus 34 Joule second. The speed of light, you know the symbol C, okay, equal to 3 into 10 power 17 nanometer per second. Which value is close to the wavelength? Here the wavelength of Planck constant, here which value is close to the wavelength in nanometer of quantum of light with the frequency. So frequency symbol mu. Mu equal to 6 into 10 power 15 unit per second. Okay, so the question, which value is closer to the wavelength? Lambda is the question mark. Okay, so within this relevant data, now construct the formula mu is equal to C by lambda. Okay, so based on the question, now to frame the formula. Question is lambda. So lambda equal to, okay, C by mu. So what about the C value? 3. Okay, so 3 into 10 power 17. 3 into 10 power 17 nanometer per second divided frequency value 6 into 10 power 15. Second cancel, remaining nanometer. Okay, so lambda unit nanometer. Okay, so next 1 3 is 3, 2 3s are 6. So 1 by 2. 1 by 2 into, okay, 10 power, this one 15. Okay, here 70. So 2. So 1 by 2, 0.5. So 0.5 here in the 10 power 2, 100. So what is the answer? Lambda equal to, okay, so 50 nanometer. Okay children, so now see the option 25, 50, 75, 10. So what is the correct option? Option B, 50. Okay, the unit nanometer. So once again children, but we never use the H, Planck constant value, because here not necessary. Okay, so now the question, wavelength lambda of Planck constant H, values given. Next, speed of light C given. Which value is closer to wavelength? So lambda question mark, express in nanometer. Okay, so 50 nanometer. And next one, light frequency. Frequency symbol mu. This much value is given. So based on this, to construct the formula, mu is equal to C by lambda. So lambda is equal to C by mu. Substitute and find out the answer. The de Broglie. Children, next question. The de Broglie wavelength of a particle. De Broglie. We know the formula. Lambda is equal to H by mv or mc. Wavelength of a particle, de Broglie wavelength of a particle with the mass. So m value given, mass is equal to 1 gram, and velocity v value is given 100 meter per second. Okay, so here gram converted into kilogram. Okay, so here H, Planck constant value 6.626 into 10 power minus 34 kilogram meter square per second. Okay children, so here gram converted into mass, kilogram. So into 10 power minus 3 kilogram. Okay, gram converted 1 into 10 power minus 3 kilogram. So now substitute. So here question, wavelength. Okay, lambda we are going to find out. H constant value, m given in the question, v also given in the question. Substitute and find out the answer. That's all. Okay, so H value 6.626 into 10 power minus 34. Okay, kilogram meter square per second by mass value 10 power minus 3 kilogram. So kilogram cancel into velocity 100 meter per second. So per second cancel, meter cancel. So remaining meter only. Okay children. So this meter cancel. So now here 10 power minus 3, here 10 power plus 2. So 10 power minus 1. So minus 1 here 10 power plus 1. Okay. So plus 1 means that is 10 power minus 33. Okay. So what is the answer? So 6.626 into 10 power minus 33. So what about the unit? Meter. So lambda is equal to 6.626 into 10 power minus 33 meter. So now here want to check the answer. 6.63, 10 power minus 33, minus 34, 35, 36. So correct option A is the correct option. Are you clear children? Next question. The spectrum of helium is expected to similar. Okay, helium is similar to. Okay, so here the spectrum here, that is talk about the electron. Okay children, so helium is similar to, here give the option hydrogen, lithium plus sodium, helium plus. First we know the helium number of electron 2, that means atomic number is 2. Okay, this is a question. So now want to check which option have the number of electron is 2, that's all. Okay, now take the hydrogen. Hydrogen number of electron 1, atomic number 1. Okay, so next lithium. Okay, atomic number 3, but here plus given. So plus means last 1 electron. So what about the electron? Here 2. Okay, sodium atomic number or number of electron 11. Helium atomic number 2, but the question is plus. So 1 electron it is last. Can you understand children? Okay, so now helium 2, here which option is relevant? Here lithium plus. So this alone is relevant. So the correct option is B. Are you clear? Once again, the spectrum of here, the spectrum talk about the electrons, number of electrons. So helium is expected to similar. First helium number of electron 2. So next want to check the option hydrogen number of electron 1. Lithium actually number of electron 3, but in plus loss of 1 electron, so 2. Sodium number of electron 11. Helium 2, but here give the charges positive, the denoted 1 electron it is lost, so remaining 1. So correct option B, Li plus. Next question, configuration of 5p1 is, that's all. This is the question, 5p1. Okay, 5 denoted as principal quantum number, this p denoted azimuthal quantum number, this one for electrons. Okay, so p orbital how many orientation? 3 orientation. Here how many electron? Only 1 electron. Okay, so represent in diagrammatic pattern. So we write 5px. Okay, this one 5py, 5pz. That's all. Here no electron. Here how many unpaired electron? Even the previous question also they are asking how many unpaired electron. Here number of unpaired electron is 1. Okay, so now in the question based on the option they are asking what about the n value as well as l value. Children, relevant the question, I talk about L value also. L is equal to 0, L is equal to 1, L is equal to 2, L equal to 3. Okay. S orbital, P orbital, D orbital and F orbital. Children, this area is very important. Okay, we expect repeated question based on this. Okay, so now which one is the correct option? Now n is equal to 5. So option A as well as option D. B and C, leave it. Next one, to concentrate in P. So L is equal to 1 means P. So where is L is equal to 1 here? So the correct answer is option A. N is equal to 5, L equal to 1. Children, next question. The number of radial nodes in 3s and 2p respectively, and here option is given 0, 2, 1, 2, 2, 0, 2, 1. First, we know the radial nodes formula. Children, based on this expecting 2 question, give the configuration and ask the question. One is radial node and another one is angular node. Okay, radial node formula n minus L minus 1. This one radial node formula. Maybe if the question they are asking angular node means very simple, only L alone. Angular node formula L. Okay, so now the question is radial node. Okay, so here 2 configuration. One is 3s. In 3s, we find out the n value as well as L value. Okay, so 3 denoted as the n value. Here S orbital. So what about the L value? 0. Okay, now substitute in the formula 3, okay, minus 0 minus 1. Okay, so what is the answer? 2. Okay, so now take the second one, 2p orbital. Now find out the n value. N value 2. This number 2 denoted as the principal quantum number. Here p orbital. So p orbital means L value 1. Okay, now substitute in the formula n minus L minus 1. 2. Okay, so next minus 1. Minus 1. Okay, so minus 1 minus 1 minus 2. Here plus 2. So answer 0. Are you clear, children? So here 2 answer, here 0. So now check the option. Option C, 2 and 0. So option C is the correct one. Okay. Children, next question. The number of 2p electron having spin quantum number S equal to minus half. Here give the option 6, 0, 2 and 3. Okay, so now according to the question, 2p orbital. So p orbital, first 3 orientation. Okay, here they are mentioning 2p orbital, 2p orbital and 2p x-axis, y-axis and z-axis. So 2px, 2py, 2pz. Okay, so quantum number. Now minus half. Minus half means, see here, this like mean plus. If you like that 7 mean plus half. It is a clockwise. This one denoted as 1 electron, clockwise direction. If we are mentioning this anti-clockwise direction. So now clockwise direction, the electron value plus half, minus half, this one remaining. Okay, so here question given minus half. So 1, 2 and 3. So they are asking the question, what is the total number of electron? So the number of 2p electron having spin quantum number. This is the 4th quantum number, spin quantum number. Okay, so minus half. So what about total? So 1, 2, 3. So the correct option is D. Okay, 3 electron minus half. Okay, so if they are mentioning both S plus half as well as minus half, what about the number of electron mean? Total 6. Are you clear? Next question, according to Bohr theory, angular momentum of electron in the fifth orbit. Okay, so even for this session, the first part, angular momentum formula written. Okay, angular momentum mvr equal to nh by 2 pi according to Bohr theory. Okay, in quantum concept, root of L into L plus 1 h by 2 pi. Okay, so now see the question, fifth orbit. So now N, center nucleus, first shell, second cell, third cell. So here fifth orbit. So N is equal to 5. Okay, so now substitute instead of N 5. Okay, so here h pi 2. So here cancel. So what is the answer? 2.5. Okay, so 5 by 2, 2.5 h pi. Very clear, children? So angular momentum formula mvr is equal to n h pi 2 pi. Okay, so now n value, the question, fifth orbit. So instead of n, substitute 5. So h pi 2 pi. So here 5 by 2. 2 2s are 4. Remaining 1. So 5 2s are 10. So 2.5 h pi 5. So now check the correct option. Here 25. Here 2.5. Here 1.0. Here 10. So correct option is second one. 2.5 h pi 2 pi. Once again, according to Bohr theory. So according to Bohr theory, formula mvr is equal to nh by 2 pi of angular momentum. Angular momentum mvr. Fifth orbit. So n value 5. Fifth position, fifth orbit. Substitute and check the, find out the correct one. Children, this is the last question. Which of the following set of quantum number represent the highest energy of an electron? Even children, based on this, yesterday we saw the topic. Okay, in alpha principle, the arrangements of electron according to n plus L rule. Rule number 2, n plus L. Okay, so now wanted to add the n plus, sum of the n plus L. Which one is the lowest n value? Write first. And the highest n value want to write next. Here the question is highest energy of an electron. Okay, children. So now write the formula n plus L. Okay, so here option n is equal to 4, L is equal to 0, ml is equal to 0, s is equal to plus of. Children, you can here concentrate first n as well as L. Okay, so now here n plus L, 4 plus 0, 4 for this option. Okay, so here 3 plus 1, 4. This one 3 plus 0, 3. Here 3 plus 2, 5. See the question, highest energy of an electron. So among this here 4, 4, 3, 5. So what is the correct option? The highest energy, option D. Okay, so children, here don't bother about n as well as s. Okay, but the question is look like that it's very lengthy one, but the concept is very simple. N plus L rule. According to n plus L rule, to find out the that is the number, total number. Okay, here 4 plus 0, 4. 3 plus 1, 4. 3 plus 0, 3. 3 plus 2, 5. So this is the highest one. So correct option D. Children, I hope you understand this session. Thank you.